All right. So welcome everybody to Jinxbot 3D Printing. We are broadcasting live from Church in Calderon, everybody's favorite little corner store. And today we're going to go over how 3D printing is changing the landscape of the startup world, as well as understanding a little bit about what's going on with 3D printing in general and with Jinxbot 3D printing. So I'll first start with a brief introduction on what 3D printing is, if you're not familiar, and then we'll go on to its kind of application on what 3D printing can do for startups or for you. So essentially what we're looking for in 3D printing is a really basic understanding. And that basic understanding comes from something that everybody has probably come into contact with before, if you've ever done home projects, is a hot glue gun. So as simple as a hot glue gun may be, that same principle can be applied to 3D printing, and then you kind of understand what that is. So essentially materials coming in from the back, and then you have a nozzle, and then that material is being shoved through that nozzle. The only difference is that we're using a much higher temperature, much harder material, and we're controlling it with a computer instead of our hands. So 3D printing, or one of the types of 3D printing technologies that we have here, is called Foose deposition modeling. That's most similar to the analogy that I just gave you with the hot glue gun. So we have around 12 or 14 FDM printers whirring away here in the background. And essentially, we're taking a plastic called PLA, or polylactic acid, very common sugar-based plastic. It's biodegradable, it's compostable, it's a pretty decent plastic, and it's very common. Like I said, you probably already come into contact with it today, being as early as it is with recycled plastic drinking cups. You look under the bottom, you can see a little symbol, and usually have a little code underneath, and that'll indicate what type of plastic it is. And I bet you that you've already come into contact with PLA before. There are other types of 3D printed plastics that you can use. One of them is ABS. We tend to shy away from ABS here at Jinxbot just because it is a fairly toxic material, very hard to recycle. It is reusable, but the fumes that it gives off, it just generally the need for ABS, the only need for it is maybe a slightly higher temperature resistance, or it has some slightly more robust chemical property or mechanical properties. But going into PLA has had a lot of development over the last 4 or 5 years. One of them being everybody's new favorite PLA Plus. PLA Plus is just a fancy term for an enhanced PLA that has some enhanced mechanical properties, temperature resistance, etc. So the gap between PLA and ABS is shrinking quite a bit. So it's really interesting to see what 3D printing is and what it can do. So 3D printing, like I said, it's extruding material onto a platform. So when someone submits a file, the basic process is a designer or yourself has come up with a 3D file. And that 3D file could be anything. It could be a prototype for electronics housing. It could be like a toy that someone's developing, a phone holder, or prosthetic limbs, or medical devices, to prototypes for VR headsets. So really, our market is anything that's kind of made out of plastic, and these days that's becoming more and more. And that's not necessarily a bad thing. Reducing and reusing is a good way to help an environmental impact, but we all do what we can, especially here at Jinxbot. So I digress. Going into 3D printing, we get tons of different customers over here, and how that's generally changing the landscape is that 3D printing is allowing for a type of manufacturing that really hasn't been possible ever before, since the 1980s. So back in 1983, a guy by the name of Chuck Hull kind of created one of the first laser printers. So not a laser printer that you might have in your home, but a laser photopolymer resin curing printer. So kind of one of the first. And it was really interesting to see that he held on to that patent for quite a few years. Companies came out of that, Stratasys, 3D Systems, and they held on to those patents for a while. And as soon as they expired in kind of the 2000s, that's when everybody kind of saw one of the first 3D printing booms. And then when that happened, a lot of hobbyists, a lot of early adopters started to get into 3D printing or additive manufacturing in general. Trying to understand what it was, what it could do, how to make these machines cheaper. So they answered a lot of those questions, but the side effect with that was that the inventing or maker community as a whole started getting tools that were never before available to them. This opened up a lot of doors and inspired a lot of people, including myself, to not only try to understand this technology, but to use it to their advantage. One fantastic analogy that I like to give is called the paperclip analogy. So when someone is understanding 3D printing and trying to figure out what it can do for them and what they can make, and trying to answer all these questions, the paperclip analogy comes in where they say, well, what can 3D printing do for me? What can I make with it? Because I can just buy a lot of things. Well, sure you can. And you can even buy a paperclip. But I can print you a paperclip, and I can print it, and it'll be exactly like a paperclip, and it will function like one, and it can even look like that classic spiral paperclip that you can. It's going to be the most expensive paperclip that you've ever bought, but I can print it for you. Where 3D printing really comes into play is if you are trying to do something truly unique or truly bespoke. That comes from you saying, okay, I don't want just any paperclip. I want a paperclip in the shape of my face, or I want a paperclip that looks like X, Y, or Z. That's when all of a sudden your options for buying an off-the-shelf face-shaped paperclip go from many to absolutely zero, because no one's ever made a paperclip in the shape of your face. That's when 3D printing all of a sudden flips it and becomes the most viable option for you to make that prototype or paperclip. Because in order to manufacture that, you're dealing with minimum order quantities, material manufacturers, you have to design the thing. So all these costs come into play when you're trying to make something absolutely custom. If you're just trying to buy a box of paperclips, you can buy one for a box of 100 of them for a couple bucks at Staples or whatever. But there's nowhere that you can buy one that's absolutely custom made for you. Of course, a lot of people in the Bay Area are not making paperclips, but they're making electronics housings. They're making new and exciting products that are changing the shape of what we do every day. I myself have a couple of pet projects. I'll show a couple off to you. One of them is, and I see we have, perfect. I see I have a question here. I'm going to address that to the side eventually, but so let me minimize that. One of these projects that I came up with was something, again, truly bespoke and having to do with my face. One of them was this pair of sunglasses. So very untraditional pair of sunglasses. I was fortunate enough to have a high detail scan of my face at a tech event that I went to a few years ago. And I took that face model, extruded it a bit, cut off the back side, and then added a faux frame of sunglasses. So here are my faux frame sunglasses that fit over my face exactly. So something like this fits almost exactly on my face without any, there it is. It fits directly over my face because it is molded exactly on my face. being able to have a 3D model of that, I could manipulate that, add in a pair of sunglasses, and even polarized lenses. So this is something that you can't buy anywhere. This is something that you have to make and 3D print. Speaking of things that you have to make in 3D print, one of the most exciting things about 3D printing as a technology is the fact that you are able to make things that have never before been able to be made. So this is poor grammar, but there's a whole slew of objects being developed these days that you can't make with subtractive manufacturing. And it's offering huge advancements in, say, like aerospace, where if you have an assembly that you needed to create via subtractive manufacturing with drilling or CNC machining, etc., then you have to bolt those pieces together. So bolting those pieces together adds material, adds weight, adds complication, etc. If you were to create that same shape with additive manufacturing, you can create enclosed objects, geometries that have never before been possible. And it's strange to me that not many more people realize the impact that that has. We're getting to the point where we can make shapes and geometries and objects and inventions that have never before been possible. And this has only happened in the last like 10 years or so. And still people are just now realizing, oh, 3D printing can do that? It absolutely can. With any new technology, there are some restrictions. So if you try to print something with like a floating piece of geometry or floating over here, say if you were to print like lettering and it has little spaces in between, that unfortunately you can't print because there's no hovering thing that we can do. But we can print all the individual pieces, and you can come up with some way to do that. So there are some caveats, but generally if you can come up with it, it can be printed and made into a thing. Jinxbot 3D printing has worked with small to medium-sized businesses, large companies around the Bay. I mean, just about anyone. And the best part of my day in particular is when I'm able to hand something that someone has dreamed up and made, and I can give it to them in real life. And that there's a bit of magic there because their eyes light up, they get really excited, and you can see the passion in their eyes about this dream that they had, this idea, and now it's come to life, where that's, again, something that hasn't been possible ever before. If you wanted to come up with an idea for something and have it like manufactured or even a small run, it would be, in the 10s, 20s, $30,000 just to get, prototyping done. And it would go from, months to years trying to be passionate about your idea. So that's a huge restriction to a lot of people who are just wanting to come up with a quick solution for something, or maybe have an idea that they want to kind of test the waters out of. Where 3D printing allows you to do is come up with 1, 2, or 10 or even 100 of a small run, much cheaper than you can do with traditional manufacturing. That's not to say that it's not going to replace traditional manufacturing for even larger scale things. I think maybe eventually there's a time down the road where I'd say 20 or maybe even 30 years down the road where you won't see any traditional manufacturing anymore ever. But I think we're still away from there quite a bit. But I think a lot of people are proving that low scale, custom, bespoke manufacturing is offering a real solution, and it's offering that solution in a really affordable way. So if you're ever at all interested in coming and learning a little bit more about 3D printing, what it is and what it can do for you, I am located at 693 Calderon Avenue in Mountain View. My door is generally, it's closed, but the door is unlocked. So in that sense, it's always open. Just give a knock at the door, or feel free to schedule an appointment with me online. I'm happy to talk your ear off about manufacturing, what it is, what it can do for you, and how it can solve any particular situation that you might be facing. So with that, I'm going to turn over to the chat box, and then there's a bit of a delay, so please forgive me. But so the first question is from Stephen Hobbs. What is the largest bed size available in your shop? So we have a FAQs page on our website, jinxbot.com. You can go online and you can see all the different machines, all the different materials that we have, as well as all the different sizes. So for FDM printing, we have bed volumes that go from 300 to 300 by 400 millimeters. So that's about a foot by a foot by a foot and some change. We also have SLA printing available, and SLA is like 145 by 145 by 175. And then we actually just got a new printer that I'm pretty excited about, called the CR30, and it's a belt printer. The neat thing about this belt printer is that it has a width and a height, but it's tilted at a 45-degree angle. And the belt printer allows, as it's printing, it's extruding that belt or rotating that belt. So you can essentially print an infinitely long object. So that's opened up a lot of doors for a lot of really cool geometries. I've printed a couple of swords for cosplay and some other frames, or some, I think there was a hydroponics unit that was quite long for a build plate, but it fit on the CR30, and we were able to print it surprisingly with very few amount of support material. So that was really exciting. So that's where our build volumes are. For building the prototypes and projects, a question from Stephanie. So it can and it can't be. Our pricing is based off of geometric volume of your part. So if you have a long part or a large part, it'll be more expensive. If you have a smaller part, it'll be less expensive. The majority of the cost of 3D printing always lies with the design aspect. So if you can find or already have a 3D printed or a 3D model in a .stl format, that's Sierra Tango Lima STL, the cost goes down dramatically. So if you're coming up with this idea on your own and you are creating the 3D file on your own, then 3D printing that file is really just a factor of the volume of material that it takes up. So we also have different levels of resolution. I can go into what resolution is, but it's also listed on our website and on our FAQs page, and with some good visuals. But the resolution will have an effect on the price as well. So 100 micron resolution being one of the finest will be more expensive. 300 micron resolution with coarser layers is less expensive. So I hope that answers your question a little bit. And then we have one from Jade. What educational background do you need to get into 3D printing? You don't need much, actually. 3D printing is really quite accessible if you're willing to sit down and learn about it. Of course, having a little basic geometry, some basic algebra, and a couple other things do help you, give you an advantage. But really, if you're just willing to invest in a machine on your own, or willing to comb some forums on how to troubleshoot a couple things that you might see be going wrong with your printer, you can learn 3D printing, and you can print a whole slew of random objects that you can put on your desk, or things around the house. My wife yells at me all the time because half the repair jobs in my house are 3D printed repairs. So you'll see a lot of that there. But feel free to reach out to me anytime. We're wrapping up here. We got about a minute left. Feel free to give me a call or an email. Our website, jinxbot.com, is up, and our email address, info@jinxbot.com, is there. Feel free to call, chat. If you have any questions, even if you're not interested in buying anything but want to learn a little bit more, we're here for you. So with that, I think that's all the time that we have. And I look forward to meeting all of you and learning about your projects and helping your dreams come to life. So thanks.